When you're working with scatter plots, you're looking for trends in the data. You're looking for some kind of relationship between the x and y values, which we call a correlation. Positive correlation means as you look at the data, you can kind of see the data increasing together. As your x value got bigger, so did your y value. A negative correlation would mean the reverse of that, so a downwards trending line, x would get bigger as y got smaller. Or possibly you're going to see relatively no correlation, meaning the data is just completely scattered. There's no trends in that data. So the first question is to figure out what kind of scatter plot we have, and it kind of takes a little bit of, well, guessing, I suppose, but we can make an educated guess. So for this first scatter plot, the data doesn't appear to be very strongly related. However, I can kind of imagine, I can see it sort of trending downward. I can imagine a downward a negative slope line kind of representing that data. If that's the case, then that's going to represent a negative correlation. And I would say that I can see that pretty well, so I'm going to say that, yeah, there's a correlation there. Oops, sorry, negative correlation. Compare that to the graph on the right over here. I'm looking at that data, and the data appears to be really random. I can't imagine one line going through that data, so I'm going to say that that's no correlation. The data appears to be completely random and no connection there. Some people say, well, you could draw a line like that kind of fits the data, and there's, points balanced above and below. And I mean, yeah, I guess that's true, but I could also kind of draw a line like that balances the data, or maybe even like that. So there's not one line that fits the data perfectly, so I'd say there's no correlation there. The next step of this then was to then estimate the correlation coefficient. This is that R value. We have 5 choices to pick from. We have -1 or +1. That would mean you have an almost perfect fit. Your points are almost in a perfectly straight line, either increasing with a positive correlation or a perfectly negative correlation. Right in the middle would be 0, meaning you have totally random data. There's no connection whatsoever. And then -0.5 or 0.5 would be somewhere between there. The data is not really close to a perfect line, but it's not completely scattered either. So one of these is easy. As soon as you say no correlation, that R value is going to be closest to 0. There's just no connection there. The points aren't even close to being in a straight line. For the other graph, the first one we did say it was a negative correlation, but we agreed, or at least I said it, and I hope you agreed with me, I guess. We said the correlation's not very strong, so I wouldn't say it's -1. I'd say it's probably closest to -0.5, because it's not in a perfectly straight line, but it's not totally scattered either. So that would be what I would pick approximately for the correlation coefficient. Now, one thing to note down here, the correlation the correlation coefficient is not the same thing as slope. So when we go to write the equation of these lines, this -0.5, it's definitely not the slope. I mean, it might be, but but by coincidence, it's not the slope at all. Just like over here, the slope is definitely not 0. A slope of 0 is a horizontal line, and we already said no one line can represent that data. So just keep that in mind. The correlation coefficient is not the same thing as the slope.